So let's go ahead and start talking about ways of locating relative extrema. Because we're going to be more often asked to find relative extrema than absolute extrema, but I'll also throw those into our discussion as well. So relative extrema occur at, excuse me, two locations. They occur at endpoints of the domain, and they occur where the function is changing direction, either from increasing to, I should say, I'm so sorry. I should say not from increasing to increasing, I should say from increasing to decreasing. That's embarrassing. Or from decreasing to increasing. So the key is we have to find those locations. So the way we check this, I like to check endpoints of the domain first. That's a personal thing. I do it because if I don't do them first, I kind of forget about them. So at the left endpoint, if the function is increasing, meaning f prime is positive, that means we have a relative minimum, because here's the left endpoint and we're going up from there. Whereas if I have the left endpoint and the function is decreasing, f prime is negative, I have a relative minimum. It's kind of backwards with the right endpoint. If I have the right endpoint and my function is increasing to go into it, because remember in math we read a graph from left to right in rectangular coordinates, that would be a relative maximum. Whereas if my function is decreasing to the right endpoint, that would be a relative minimum. To find where a function is changing directions, we look at what are called critical points, which is where the derivative is 0 or undefined. So with the derivative being 0, that means we have a horizontal tangent. And so when we did motion, we looked at this idea that, hey, when I have a horizontal tangent, there's the possibility of my object changing direction. So if I have a critical point, meaning there's a horizontal tangent, and my function changes from increasing to decreasing, this would be a relative maximum. If I have a critical point with a horizontal tangent, and my function changes from decreasing to increasing, that would be a relative minimum. Now you do have to be really careful. Just because the derivative is 0 or undefined doesn't mean that there must be a relative extreme value there, because we could have a case where the function just flattens out for a moment. An example of this would be x cubed. At 0, there is a horizontal tangent, but my function's increasing, briefly flattens out, and then continues increasing. That's not a relative extreme value at 0 then. So just watch out. Being a critical point doesn't make it be a relative extreme value, but if there's a relative extreme value, its derivative will be 0 or undefined. In terms of the methods we're going to be talking about for finding extrema, there's one called the candidates test, there's one called the first derivative test, and there's one called the second derivative test. I will have videos for each of these separately.